Hello class, welcome to today's lesson in which we're going to continue understanding the concept of energy. If you remember guys, I already told you that energy, this concept of energy, is basically the ability of a particle to do work on some other thing, right? And I gave you the example of the box in motion doing work on a spring, right? Okay. Now, there are different types of energy, one of which is what we know as the kinetic energy. And I'm going to explain to you what this is, kinetic energy. What is the definition of kinetic energy? The kinetic energy, let me grab a pencil. The kinetic energy is the energy a particle has due to its motion, or we can say that it's due to its velocity. And the kinetic energy is defined mathematically in the following way. We're going to write a K to represent kinetic energy. All of this means kinetic energy. And that's going to be defined as 1/2 times the mass times the velocity squared. The mass of what? The mass of the particle. And the velocity of what? The velocity also of the same particle. Sometimes you can write this also. I mean, it's going to be the same. Mass times velocity squared over 2. This and this are mathematically indistinct. Where m is the mass of the particle, like I told you, and v stands for the velocity of the particle. The kinetic energy, since its energy is going to be measured in joules. Any type of energy, it doesn't matter whether it's kinetic or chemical energy or electrical energy, any type of energy is measured always in joules. Now, let me give you some examples, guys, of what we mean by kinetic energy. I'm going to give you 3 examples. For example, think of a speeding bullet, a bullet that just came out of a gun, right? You shoot the bullet, and therefore the bullet is going to have some velocity, usually a very high velocity, right? So we say that this speeding bullet is going to have kinetic energy. Why? Because it's in motion. It has certain velocity. And therefore, due to since it has kinetic energy, it can do work on anything it hits upon, right? For example, look at this. Okay, well, let me tell you what this is. So what do we have here? We have a gun. There's a bullet in the gun waiting to be shot. There is a block of wood which is suspended from 2 strings. This is all the arrangement. Okay, now what's going to happen in a moment? I repeat, the bullet is gonna be shot. It's gonna come through the barrel of the gun with some velocity, and therefore it is gonna have some kinetic energy. Actually, a lot of kinetic energy because the velocity is very high. And then, therefore, since the bullet has energy, it can do work on something else. And remember, guys, what is work? Work is, if you remember, let me write that down here, is applying a force over a certain displacement, right? And then we have this other thing, the cosine of the angle between the force and the displacement. But try to forget for a moment about this. Basically, we can think of work as applying a force over a certain displacement. So I'm telling you that the bullet, since it has energy, it can do work on this block. It's going to be able to do work because that's what energy is. Energy is the capacity to do work on something. So the bullet, what's going to happen is this. It's going to impact, it's going to hit the block, and then it's going to apply a force on the block over a certain displacement. Let's see the video now. It's going to appear in slow motion. There it is. You see? One more time. Let's do it. As you can see, the bullet will apply a force over certain displacement. All of this displacement. Okay, so you can see that the bullet had energy because it could do work on the block. Second example, Bruce Lee's fist moving forward has kinetic energy. It can do work on anybody he punches. Let's see. Look at this. And well, yeah, this one is fine, I guess. Is there anything larger? Okay, this one's better. So basically, what's happening here? He already not good. Okay, let's use that one, even though it's small. What's happening here? Pay attention only to Bruce Lee's fist, el puño. So basically, what he's doing is he's moving it forward, right? He's giving some velocity to his fist, and therefore, given that fact, we can say that the fist is going to acquire kinetic energy, right? And then that kinetic energy is going to do work on the body of this person. In other words, the fist will apply a force on the chest of this other man, will apply a force over a certain displacement, right? Okay. Number 3, a hammer that is accelerating downwards can do work on a nail to insert it on a board. I believe I already told you about this example, but let's go over it once again. So imagine you have a board and you have a nail on top of it, like that. But this nail is not yet inserted on the board. It's just barely, just a little bit, you know, just enough so that it can stand vertical. And then you have a hammer in here. Okay, so once you give velocity to the hammer downwards, once you put it into motion so that it approaches the head of the nail, what can we say about the hammer, about the head? This is the head, right? About the head of the hammer. We can say that head is going to have kinetic energy, right? Why? Because it's in motion. And therefore, since it has kinetic energy, at the moment it hits the nail, then it can do work on the nail. What is work? Is applying a force on the, in this case, in the tip of the nail. It's going to apply a force over a certain displacement, right? It's going to drive the nail downwards and it's going to insert it on the board. So due to the fact that the hammer or the head of the hammer was speeding downwards, we can say that it has kinetic energy and therefore it can perform work. On what is it going to perform work? On the nail. You see, that's how kinetic energy, that's what kinetic energy means, and I just gave you 3 examples. Okay, now what is potential energy and what is gravitational potential energy? First of all, I need to tell you that potential energy is a wide concept. Like it has, there are many types of potential energy. One of which is gravitational potential energy, and this is basically the only one that we're gonna study in detail. But let me tell you what potential energy is first. Potential energy is the energy that a particle has due to its configuration. And why am I placing an asterisk right here? Because this may sound a little weird for you. This is a little confusing, right? What does it mean that a particle can have energy due to its configuration? Well, that's a little tricky to understand by the moment, and I understand if you are a little confused. If you want not to pay too much attention to this definition, let's go with this one better. Potential energy is energy waiting to be released. And because, you know, that's what we mean by the word potential, right? For example, when we say that a person has potential, what we mean is that he can release that later and achieve some things, right? But he hasn't done that yet. Having the potential means that you have something accumulated and you can release it. That's the idea behind potential energy. It's basically energy waiting to be released. And there are many types of potential energy. We have gravitational, chemical potential energy, elastic potential energy, nuclear potential energy, and so on. For example, let me tell you an example of chemical energy is food. Okay, think about a peanut, for example, or many peanuts. Okay, there is chemical potential energy accumulated in these things, in peanuts. Once you eat them, once you eat all the peanuts, this potential energy, this chemical potential energy is going to be released by your body once you have digested the peanuts, and therefore they're going to allow you to do work, right? With your own body. You can do work on whatever thing you have, right? It's going to allow you to move things around and so on. If you don't eat food, guys, you cannot do work. You cannot apply forces on anything. You see? So that's chemical potential energy. Another example of chemical potential energy, think about a battery like Duracell and those things. Okay, when you connect this thing to any device, I don't know, a little train or something, like, okay, when you connect these things, the chemical potential energy that is accumulated inside is gonna do work on whatever system that you connect it to. In this case, I'm telling you of a little track in a train, and so the energy that is accumulated here, which is potential and is chemical in nature, is gonna put the train in motion. It's gonna apply a force on the train so that it works. So that's chemical potential energy. What about elastic potential energy? What is that elastic potential energy? Let me give you some examples of that. For example, look at these guys. We have this arrangement. I know this looks, I'm not playing the rest of the video because it's way too long, but the only important thing is this. Look, I'm gonna silence it. So what do we have here? We have a spring. We have a spring, un resorte. And pay attention to what this man is gonna do with the spring. Okay, he just compressed. He just compressed the spring. Can you see? Okay, now at that moment, guys, when this person compresses the spring, we say that there is elastic potential energy accumulated in the spring. Okay, I'm gonna repeat that. There is elastic potential energy accumulated on the spring waiting to be released. Look, he's putting a ball right there, and look what's gonna happen. Oh, well, no. That one. Look, there you go. You see? Look, he's gonna do it one more time. Let's actually play it a little slower. Okay, right now he's compressing the spring, he's accumulating elastic potential energy, and then he's gonna release it. And ignore this ball. This ball is not important. This one is important for us. So look what's gonna happen now. Releasing the potential energy. There you go. You see? The elastic got decompressed, and therefore it could do work on this ball. In other words, it applied a force on this ball over a certain tiny displacement. Look, there you go. You see? So in this case, we have an example of elastic potential energy getting released and doing work on this particle, which means applying a force on the particle over a certain, in this case, it was a tiny displacement. Like that. Okay, so that's what we mean by elastic potential energy. Another example, when you play with an arc, and an arrow, right? So look at this, guys. At that moment, when he's pulling this back, now he has accumulated potential energy, and now he released it. Once again, at that point we have accumulated potential elastic energy, elastic, and then he releases that energy. That's what we mean by elastic potential energy. Okay, so I just gave you examples of chemical potential energy, elastic potential energy. What about nuclear potential energy? Well, bombs. Okay, nuclear bombs, for example. Those things are devices that have accumulated nuclear potential energy. When these people drop these things on cities or whatever, then that energy is released. Okay, now what about gravitational potential energy? Even though there are many types of potential energy, like gravitational potential energy, chemical potential energy, elastic potential energy, nuclear potential energy, and so on, the only potential energy that we will investigate is gravitational potential energy. And what is it? Gravitational potential energy is the energy that a particle has due to its height with respect to the ground. Due to its height with respect to the ground. Gravitational potential energy is given by this formula. And by the way, we're going to represent gravitational potential energy with a U. Don't ask questions about why. It's just a symbol, guys. Don't worry about the symbol. When we write a U, we mean gravitational potential energy, just the same as when we wrote K for kinetic energy. Don't ask why it's a U. It just is. Don't worry about that. And it's gonna be equal to the mass of the particle times the acceleration of gravity, which is 9.8, right? Meters per second squared, and then the height above the surface in which you have the particle. For example, if this is the ground or the surface, the floor, and this particle is at a certain height from the ground, then that's the height that you're going to place in here. And once again, the gravitational potential energy, since it's energy, is going to be measured in joules. Now, let me give you one example of what we mean by gravitational potential energy. One or two examples of this. For example, think of a rock on top of a cliff. Let me draw that. A cliff es un precipicio. So imagine that we have a cliff. So we have this elevation, and then a cliff, and then more land, more ground. And you have something in here that you want, I don't know, let's say you have a log that you want to, for some reason, you want to stick it into the ground. Okay, so you need to apply a force on this log in order to drive it downwards towards the ground. You want to stick it for some reason. We don't care about the reason. So in order to do that, guys, you need to apply a force on the log over a certain displacement, right? You need to apply a force over a certain displacement to drive it downwards. Okay, that may be a difficult task. Let's suppose that you don't have enough force to do that. Perfect. What can we do? Well, I don't know why I erased that. Okay, I just wanted to erase this. What can we do instead if you don't have enough force? Well, suppose you have a very big rock in here on top of the cliff. You can get it closer to the fall, and then you can just let it go, right? You can just push it so that it's gonna hit the log, and it's gonna do the work for you. This rock. Okay, so let's think about this, guys. When the rock is here at a certain height from this level, from this ground level, we say that this object has potential. Well, we say that it has gravitational potential energy. In other words, it it has accumulated some energy due to its position with respect to this surface, with respect to the ground. It has some energy waiting to be released. When we push it with our hands just a little bit so that it goes downwards, that potential energy, which in this case is gravitational, is going to be released and is going to be able to do work on this log to drive it downwards. You see, that's what we mean by gravitational potential energy. In this case, this object has gravitational potential energy because it's at a certain height above this surface or above this level ground. Another important example of gravitational potential energy is a dam. A dam, in case you don't know, es una presa de agua. That's a dam. So let's see, a dam can release the gravitational potential energy of the water, and by doing this, it can do work on turbines. Let me show you what that means. Look at this, guys. So this is a dam, and I mean, you know what it is, right? It's just una presa. Okay, look at these things. These are dams. What is happening, guys? Why do we want these things? Why do we build these things? Because we can do the following. When we open the doors of the dam, like in these images they're showing you, right? What's going to happen is that the water, which is at a certain height from this ground, can you see? Look, the water that's going to fall is at a certain height from this level. You see, this water is at a certain height, which is this height, with respect to this level. The same in any case. And therefore, since the water is at a certain height from the ground, we say that the water has gravitational potential energy, and we can release that energy when the water falls down. And then that water, guys, look at this image here. This is the dam. When the water falls down, it's gonna impact on some turbine. Then, therefore, the water is gonna do work on the turbine, and the turbine can activate a motor. You see? I think this image is more. Okay, look at this. You have the reservoir, and then the water is gonna fall down. It's gonna travel here. It's gonna impact the turbine, and it's gonna move it. In other words, it's gonna apply a force on the turbine. It's gonna do work on the turbine, and then the turbine will generate electricity for the powerhouse so that it can light up the cities and all these things. Okay, so that's how we use a dam. Basically, the dam releases all this potential energy accumulated by the water, and when these doors are opened, the water is going to fall down, and all of that gravitational potential energy will impact some turbine, and it's gonna do work on the turbine in order to create, in this case, electrical energy, in order to light up your house and so on. That's how we use these things. Okay, now next I have 4 exercises, but I think I want to do this with you live. These are very simple exercises about calculating kinetic energies and potential energies. They're extremely simple, and we're gonna do them in class. So let's get started, guys.